Alrighty, alrighty. There, Australian morning for the top of the morning for you. Guys, I got a little curl hanging out. I'm just gonna leave it. You know what I mean? You know what I mean? Okay, so quick update on life. What's going on? Got a CTO meeting at 8 o'clock is CST for me, so I will have to hop off this in 28 minutes. Hopefully we have enough time to get through this in 28 minutes. I don't know if we will, but just heads up on that. So that's been going great. We're building sentiment. Our company is coming together. We got our CTO. We got a few things more lined up. David's been out at the conventions trying to get some money for us. It's coming together, folks. Built this whole encryption layer. This is total tangent to backend engineer. I just wanted to show you guys because golly, it's freaking sweet. I built this encryption layer, got Stripe integrated, got all this fun stuff. Let's see. I want to show the encryption layer because this is a bit novel. So all this data is being encrypted, and unless you have the user's secret environment key, you can't see the data. Look how cool that is. Unless you have the exact key. So the user has to share their key. Let's see. Something's broken here. All right. Well, we'll fix stuff later. Not today. Not right now. Yeah. I don't know what's going on. I don't know what's going on. Something's broken, but I should be able to get their key to actually see the real data. But yeah, we have real users, and I know some of them, I was doing some analytics and stuff. I know some of them are from Pakistan, India, America. We have like New York, California. We have Mumbai, India users. It's pretty sweet, guys. So I'm pretty pumped. Anyway, you know what's even cooler than that is learning back-end engineering stuff and pure functions. That's the coolest of it all. So let's dive in. Let's dive in. Okay, so pure functions. What are these? Well, they're pure and they're functions. My understanding of pure functions initially are they always return the same output with like no zero variance. They're pure. So that's my bird's eye understanding of pure functions. Let's dive in. Again, 26 minutes, folks. Hell, I have to get off. I probably have to get off actually sooner, but just throwing it in there in advance so we're all on the same time frame. I love doing this, by the way, so thank you in advance for your time. Let's dive in even more. So pure functions, what are they? If you take nothing else away from this course, please take this away. Take me away. Pure functions are amazing. Okay, so a pure function has two properties. Two, not one, but two. They probably have a few more, but two they are highlighting here. It always returns the same value given the same arguments. So a bit of the opposite of a hashing function. Its evaluation has no side effect. A pure function is a computational analog of a mathematical function. That's a big word. I don't know what that means. Let's look at the wiki. Let's look at it. So a pure function in computer programming is a function that has the following properties. These two things. It returns identical values with identical arguments. The function has no side effects. So there's no weirdness. There's no random variable. There's no variance. There's no IV. There's no initialization vectors. There's no date timestamps. There's none of that stuff. You put something in. If it's the same something, you get the same something out. Okay. Here's an example of a pure function. Max value float. Right now is -0, negative infinite. And then you loop through nums and return the highest value. If that value is higher than the next num, return it as the highest value. So that's an example of a pure function. Here's another one. We have a global max. That is cool. Did not know you could do that. That is cool. So note on purity. While purely functional programming excludes mutable variables, meaning loops are disallowed, pure functions are just one part of functional programming. Pure functions can still have loops and mutate internal state. They just can't mutate state external of their scope or have side effects. Okay, so you could do stuff still within the function scope, but the second you start pulling in variables, so I guess to some degree this probably wouldn't classify as a functional programming deal, but I suppose maybe this one would, is my understanding when reading this between the two. Okay, so assignment. There's a bug in convert file format function. As it stands, it depends on some data that isn't scoped locally within the function. Those global values are mutated by external functions and are not guaranteed to be the same every time convert file to format is called. Fix the bug by making convert file to format a pure function. Okay, so it looks like we are doing some shenanigans here. We have a target format. We have a valid conversion. We import a file in a target format of where we want to convert the file to. So let's run it. Let's see what the actual bug kind of is. So we're expecting invoice.md and we're returning none, which means we have something going on up here, I imagine. So let's format this just a tad so we can read it a bit more. So if current format invalid extensions, so one of these guys, and target format invalid version. Okay, so we have, one of valid extensions is right above it. Find item, replace the format with target format. Okay, let's print the file name real quick and let's just see what we're dealing with. So I'll put a bunch of stars right next to it. So invoice.txt is what we're given, and it looks like we just want to swap it to some sort of target format. So we'll put that one below. So we want to swap it to MD. Okay, so I don't think it's actually going to be, so current format, we're taking the back end here. So let's print that out as well. Let's see. I don't know if we need all this nonsense below. That's a lot, right? So we remove the current format right here, or this is the current format. So first of all, we need to check if this is a valid format. So I like that. So check if it's valid. I'm going to split this up into 2 bits of logic. Just my brain works a little simpler doing that. So let's say we'll say if not current format invalid this, we'll return none. So I'm just doing the opposite, right? Meaning we can now get rid of this bit because this now handles that logic. So if the current format is not invalid extensions, return none, I believe. So we still should have the same thing, right? Or not. Can we do something like this? Not in. If current format, what if we nest it like this? So then we can keep going, right? So if current format, boom, boom, boom. Okay, right? We get our extensions back. Does that work? So we really can't do that. That stings. I thought we'd be able to do that, guys. Sorry, I'm a bit of a Python. Oh wait, no, that still does work. Oh, okay, perfect. Okay, I don't know why. I just saw the stars and thought it didn't work. Okay, so that does work as a guard clause. So that's awesome. So that helps clean it up in my brain a bit. So we could just focus now on this logic and see what's going on here. So we have this. So if this is not in that, boom, not a problem. Let's just focus here. So if current format is not invalid extensions, we'll just return none. Else, basically we want to do this. So if target format is invalid conversion extensions by this format, right? So we're looping through the object, and then we're taking our current format, using that as a key to figure out. So in this case, we're going down to valid conversions. We're going down to the MD key for this one because that's our extension, and then we're replacing the file name. Looks like current format with the target format. So if this is the target format is txt, I'm not sure what's actually not returning, to be honest. That seems appropriate. So fix the bug by making this a pure function. You know what? I wonder if it's just as simple as, right? Like just, there we go. All right, so I was doing all this. It was really just that simple. Well, that'll work. I like it. That's simple as is. So example 1 is, let's see. It looks pure because it looks like it's manipulating or mutating data inside of the function scope. This looks like it's not pure. So let's try. So the first one is pure. Let's see example 3. Let's say it's impure because it's importing something outside of the scope of the function. Good to know. So pure function review. Let's see. Pure functions have a lot of benefits. Whenever possible, good developers try to use pure functions instead of impure functions. Remember, pure functions return the same result given the same arguments. They are deterministic. And I like that. Thinking about a pure function in this way is their scope is all handled within the function. So if you're changing your file, nothing's going to affect it, right? So I think that's part of why they're developed the way that they are, because if it's something where, let's say you have a file with 200 lines of code and it's dependent on, and some of the functions are dependent on some of the data and stuff happening in the file elsewhere, then obviously you could see very quickly how you could dirty up your functions and functionality of how it may work. So let's see. So example 2 is impure, I would say. Sweet. So, okay, so reference versus value. Sometimes when you pass a value into a function, the function can change the original value. In other cases, the function receives a copy, and so any changes made to the copy aren't seen by the caller. There is a bit more Pythonic nuance to it, but this is a mental model holds for our purpose. Pass by reference, a function can mutate the original value that was passed into it. Pass by value, a function cannot mutate the original value. Okay, so with relations to peer functions, I think what they're saying here is a peer function is past data, and within the scope of that function, when you're mutating that value of the data that's passed into the function, it actually makes a copy of it. So then you can do whatever you want, and it doesn't actually affect the data. However, again, if we're importing global data and just directly mutating it in the function, I think that messes with the global data or can mutate the global data. I think that's what they're saying here. So in Python, these types are passed by reference. Lists, dictionary, sets. These types are passed by value. So again, reference can mutate the original value passed to it. Passed by value cannot mutate the original value passed to it. So these are not getting mutated, but these ones are. I don't know. I'll have to see. We'll have to see. We'll have to muck around to see what's going on. So generally speaking, most collection types are passed by reference except for tuples, and most primitive types are passed by value. So example of reference. So all of our lists, dictionaries, etc., and our primitives are immutable, I suppose. That's awesome. That's awesome to know. Okay, so assignment. We have a way for doc-to-doc users to set up their supported formats and their settings in memory. We store those settings as a simple dictionary. Here's a simple dictionary, just key value store. PDF, docs, text, and you can, looks like Boolean, turn on and off these settings. Unfortunately, there is a bug in our code. When a new format is added or removed, it not only updates the list, but it changes the defaults themselves. That is not good. That is not good. Oh, I see. So we have defaults being configured when we're adding them to true, but it changes the defaults themselves. So we obviously don't want to do that. So fix the bug by making add format and remove format peer functions that don't mutate their inputs. So you can see here, we're assigning the new inputs. But I suppose we just need to say default formats. We just need to add default formats, right? So I think it's just maybe this instead of assigning it a value of false, maybe. No. Okay, let's take a peek-see at the data real quick. So print default formats, and we'll print default formats again right here. So let me add some stars. Boom. We'll add some stars and we'll say lower just to see the lower bit. Okay, so I'm not seeing the output here. So actual default fail. I don't see the output. I don't see it. I don't see the default formats. But I can't imagine this is, let's see. So default formats at the new format. What about if we do something like this? No, 0th one. Let's see. I just want to see what the list roughly looks like so I can kind of get a better mental model. I'm such a visual learner that sometimes for me to understand stuff, I just like need to see the data. So, okay, so default formats in the old format, we're assigning it to false and returning the default formats. So what is going on? So it's mutating the list. So default formats, and then we're mutating the list. Fix the bug by making add format and remove format peer functions that don't mutate their inputs. So if we just remove these, so expecting false, MD, true, default formats, okay. So if we add a format, I guess I'm not understanding why it mutates the old state. So default formats, what I could do is maybe make a list. So I'll say copy formats, right? What I could do is say copy of formats equals this. Maybe. So that way we're copying a list and we're not actually returning the real state. Oh, maybe I got these backwards. Copy formats equals default formats. Let's see, guys. So maybe I need to initialize the list even, right? So copy of formats equals this, and then we assign it to this, and then we mutate this thing, and then return this thing. I feel like that works, but what they don't want us to do. Oh, the copy method can be used. Okay, cool. So that's exactly what we're going to use. So we'll say boom, this, and then how about that? And how about now? How about now? How about now? Son of a gun. Son of a gun. So copy formats equals an empty dictionary, and then we'll do this, right? Nope, still not an enchilada. Okay, let's stop mucking around. New formats equals default formats.copy. Okay, So we had the right idea. Just execution was not there. Execution was not there. But it worked. It was the right idea. So default formats.copy, was this what they did? Sometimes I see code and just immediately forget. It's kind of funny to me. But okay, so all we did is just pull in that object, make a copy of it, mutate the copy, return the copy. But I thought what they were asking was something different, so it wouldn't append a value to the copy of format. So maybe a misunderstanding here. Okay, so a peer function can mutate its local variables, yes. Mutate its inputs, no. Mutate its global variables, no. Call functions that mutate global variables, maybe. But I'll go with mutate its local variables. Seems like the most thing. So peer functions execute faster, easier to debug, read, and test. This is true. Guys, I'm going to wrap it up here after this one. Let's run through it together real quick. I think that's about a good halfway point, and then I'll be able to hop into my 8 a.m. meeting with our CTO, and then I've got a meeting with our old CEO, my old CEO from Babson. He's a fantastic guy, amazing guy. So super looking forward to chatting with him, asking him some silly VC questions and things of this nature. For me, I'm a dash green to the space, so it's obviously smart to be around smart people. So anyway, so input and output. The term I/O stands for input and output. In the context of writing programs, it refers to anything in our code that interacts with the outside world. Outside world just meaning anything that's not stored in our code in memory, like variables. So example of I/O, reading from or writing to a file on the hard drive, making a network request across the internet, some HTTP stuff, reading from or writing into a database. Simply printing to the console is considered input and output. Sometimes we call I/O side effects. Okay, good to know. So in our doc-to-doc, we frequently need to change the casing of some tags. For example, we want it all lowercase, we want it all uppercase, etc., etc. So there's an issue. I gotta sneeze. Woo. Okay, there is an issue. Golly, there's an issue. That's for sure. Okay, so there's an issue, convert case function. Our test suite can't test this behavior because it's printing to the console a side effect instead of returning a value. Fix the function so that it returns the correct value instead of printing it. So we just need to return these values, it looks like, instead of printing them. We could keep printing them as well, but I'll just return them all. Oh, that's cool. You could do text to title case. Let's try that. Boom, pass. Nice. Okay, that was an easy debug. We kind of had that. So I/O and functional programming should be avoided completely. Strewn all throughout the project. Only used when assignment. That's funny. So we'll say limited specific parts of the code base. Seems appropriate. Let's see if all these are just questions that we could just burn through real quick. So I can only print does nothing. Let's see. So can read from an external database. Oh, oops. So from the user's perspective, a program with no input and output does nothing. There we go. Alrighty. Let me just double check these real quick. Yeah. So I wish I could stay on for a couple more minutes, but I do have to run through. Maybe actually, I don't know. Maybe I could actually run through this really quick. Hopefully the guys don't kill me. So let's go to the assignment. So complete the markdown text to function. It's currently a no OP. It should remove any hashtag characters from the beginning. Headings markdown. Boom, boom, boom. Let's see. So maybe we could print this doc content real quick. Well, that's funny. That's a perfect deal. Okay, so boom. So we're going to say this split, and we're going to split on any hashtag characters. Remove any of that. So I'll actually remove any single or double. Boom. So what if we do this and split, and then we print the document after? What would that look like? Let's reassign. Boom, boom, boom. What does this do? Not an intro. Okay. I'm gonna rush through this. This is gonna be bad. This is gonna be bad, folks. Come on now. Okay, so boom. Oh, I feel nasty doing this. I feel dirty doing it. But guys, I gotta get through this because now I'm in a weird spot of doing a really short episode on the tail end on peer functions or doing it. So let's just kind of review the logic here and then run through it. So it looks like markdown. We assign lines to. We're splitting everything on a new line. Okay, and then we take the new lines, do a lambda function through it. We're removing the asterisks from the lines and returning it. So that's step one, is remove asterisks Oh, but we're also stripping, let's see, we're removing asterisks from the stripped hashtag lines. So lstrip looks like it's a Python deal. It's a Python method that looks like we can just rip things out of it. So lstrip right here just looks like you could just remove characters you don't want. So anything of this, a comma, a dot, or ASW, looks like we would remove all of these things. So it would just return banana or B in, I imagine. Let's see what it does. If we return lstrip this, oh, it just returns banana. Okay, so any of these words together, I suppose. And then we're removing the asterisks here. So words, lines, split. So we're splitting the line into words. So a sentence gets into words. We're defining clean up the word, stripping the asterisks if the length is greater than 1, else return the word. Okay, cool. And it looks like there's a filter with the lambda function of the words. Okay. Let's submit. We're on to the next. We're on to the next, folks. We got to cruise. I got 220 seconds. The gun is against me right now. So memoization is not memorization. Memoization at its core is just a specific type of caching. It's when we store a cache or a copy of the result computation so we don't have to compute it again in the future. Oh, that's sick. Okay, let's look at the solution. See what's going on here. So we're storing a copy of memos. Side note, there's a scam project with crypto that did memos. So this makes me question, well, the boot.dev. No, I'm just kidding. But it was a cool project. There are cool intentions, but just obviously rug pulled a lot of people. Okay, so it looks like the count, word count. So they store the count in the function. And that's one of the answers. So new memos, let's see. Complete the word count, boom. Okay, we're going to submit and run. Guys, we're going to submit and run. So it looks like, which is not equivalent when evaluated, boom, 3 plus 3 plus, ooh, this. That's a string value. Okay, so memoization trades blank for blank. Memory usage for speed. Speed for memory usage. Oh, it was memory usage for speed. Guys, I got to hop on the call at 8 a.m. I appreciate your time so much. We learned a few things on peer functions today. It was a good time. I will see you on the next one. Cheers.